Another good example is product leadership. And if you think about an iPhone or an iPad, which most of you probably have or want, those are great products, but they're really nothing without the cloud, right? An iPhone wouldn't work without, in effect, cloud-based telecommunication services. You wouldn't have any games or apps on there without the, Apple App Store to be able to download them from. And moreover, services like Siri ultimately are delivered from the cloud, right? The devices don't have the intelligence, and it doesn't matter how smart or capable those devices go, because the one device in your hand will never have the power of 100,000 or 500,000 servers available in the cloud. So that enhances things. But it's not just endpoints like iPhones or iPads, because you can differentiate products like cars and sneakers via the cloud. And a good example of that is real-time maps that are delivered into your in-car navigation system, including traffic congestion, even sneakers, Nike Plus or Fuel Band. What they do is they're differentiating some plastic and rubber and cotton using the cloud, right? In other words, it isn't just a sneaker that you're buying anymore, it's a brand and an ecosystem that basically you can take your routes run, your paces, do against your personal best, load that up into your social network, and so all that stuff ties together. And again, don't think of this from a technological perspective, although that's interesting, but from a business perspective, which is you're selling peanut butter, light bulbs, jam, cars, sneakers. Yeah, you need to do things around brand, make it seem cool or cheap or expensive or whatever you want to do to differentiate your product, but the cloud increasingly is critical. Customer intimacy is another example. Anytime you order a book from Amazon and it says, because you like this, you may like that. I can't read that number, I'm sorry. 50 minutes left? Okay, thank you. Oh, 5. Okay, got it. So customer relationships can be differentiated. I would say that Amazon or Netflix knows more about what I'm likely to like in a movie than I do myself, right? And so that in turn increases customer stickiness, makes me less likely to go to a rival, and this is also worth big bucks. Lastly, accelerated innovation through things like open contests and open innovation that lets a company that's trying to innovate new products and services tap into all of the expertise in the world. One great quote here is Procter & Gamble, where the quote is something to the effect that we have 9,000 scientists inside the company, but there are 1.8 million outside the company. So if you're just playing the numbers game, it makes sense to try and leverage that outside expertise where possible. Briefly, IT in the cloud can substitute, so people complain about energy use in data centers, but the fact is that a video conference via the cloud certainly uses a lot less energy than a bunch of people hopping on a plane and burning jet fuel. In terms of optimization, like the route optimization that I mentioned, it probably makes sense to spend $1 or $2 on computation and save tens of thousands of dollars on fuel costs. I think data centers create jobs. People complain, well, the number of people in a data center is so low that they're irrelevant. Yeah, that may be true. Just try and shut Google's data centers down under the idea that you'd only would lose like 50 or 80 jobs. There goes 50,000 jobs. So as the world moves to IT and services and quote unquote, as Mark Andreessen says, software eats everything, this all becomes important. All right, in my remaining few minutes, I'm gonna cover some math real quick. This is my definition of cloud. I think it's common, in other words, pooled resources, location independent. Doesn't matter where you are or where your telecommunications, collaboration, social network servers are. It's online, in other words, accessible over a network. It's a utility, in other words, there's a pay-per-use pricing mechanism, and it's on demand. In other words, resources are available whenever you want them. This is a very generic model that has nothing to do with computing per se. This applies to hotels, electricity provided through a utility provider, et cetera. And as a result, there are actual principles behind all this stuff. So under the commonality, there are statistical multiplexing effects that can reduce a penalty cost function. Under location independence, there are diminishing returns for node build-out as you try and reduce latencies among points. There's a spherical aberration effect that's relevant, so that's that double angle formula. It's all online, and therefore you get these trade-offs between point-to-point networks versus hub or mesh. It's a utility, and there's an optimization point around owned resources and dedicated. That's why you may own a car but also take cabs sometimes, or own a house but still stay in hotel rooms. It's cheaper than either owning a house everywhere you might be or living in a hotel all the time. I haven't done benchmarking on dorm room expenses, so I'll have to get back to you on that. And lastly, the value of on-demand, in other words, delays required for resources, varies based on the variability and nature of the demand function. One interesting one is if the demand is exponential, any fixed provisioning delay leads to an exponentially increasing penalty function. In other words, you fall further and further behind. So even if you can provision servers in a day or an hour or a minute, or then data centers within a year, if you're a company and they keep varying over time, a year ago you talk about Zynga and Facebook, I'm sure there's the new thing coming on board now. 5 years ago or 10 years ago you talk about MySpace, but as you're trying to grow exponentially, you can't deal with the resource provisioning quickly enough, and so you end up losing customer revenue. For those of you that are the hardcore computer science people in the audience, I did for fun formulate what I call axiomatic cloud theory. This is about as rigorous as you can get. It's based on set theory, function spaces, metric spaces, et cetera. There's a paper, you can just Google axiomatic cloud theory and download it. But the point is that you can actually come up with an extremely formal structure for then assessing some of these stat muxing effects, et cetera. Briefly, because I know I'm running out of time, I love the cloud, but I don't think the cloud is the only answer. It's more like a position in space, in a 5-dimensional space that has these characteristics. I can have common resources or dedicated resources. I could be location independent or location sensitive, et cetera, et cetera. And so it becomes interesting to explore trade-offs and also where the optimal points are for hybrids. And just some of those points really quickly, this shows NJIT.edu Pageviews. You can see there's a high degree of variability, about a 2-to-1 peak to average ratio. That leads you to a few insights. For example, if you just have one such set of demand that you're dealing with and you build a peak, you have 50% utilization or less. As you start stat muxing those demands through a cloud service provider, an infinite number of independent demands leads to 100% utilization with resources sized to the mean rather than resources assigned to some peak which may be unpredictable and therefore not unbounded. That leads to some interesting conclusions. For example, the 1 over square root of n function leads you to some insights that say if you can only multiplex 2 demands, that's good, or 4 demands, that's good. So if you're a diversified company, that's very effective. But if you're a large cloud provider, even if you're a mid-sized provider, you can get to within a few % of the theoretical optimum cost that an infinitely large cloud provider could achieve. Speed is important. Great data from Google. Net result being that today we're dealing with 2 factors. One is both interactivity and high bandwidth. And video is obviously, streamed video is high bandwidth, but not necessarily low latency. Video conferencing is high bandwidth and low latency. And things like progressive search, where as you type keystrokes, you start to get search responses back, is low bandwidth, but also low latency requirement. This leads you to a new paradigm for computing. I'll sit down in a second, Katia, which is the old days you had the Turing machine model or finite state automata. That is no longer valid, I don't believe. Then it went to the sort of the parallel processing model back a while ago, and that leads to Amdahl's law, which is as you add servers, you have a 1 over n effect in terms of the parallelizable portion of the workload, but the serial portion remains the same, which leads you to limits to speed up. But these days, I think there's a new law, which I call the law of cloud response time, that says I've got some time at the endpoint, some time across the network, some time at the remote server. As I parallelize that, for example, Google uses 1,000 servers to process your search query, because doing it on one would take too long. So I can reduce that time a little bit, and then of course I've got response time, and there may be some number of round trips that's application sensitive. That leads you in turn to a formula for single processor and single network transaction. As you get to multiple nodes, you get that square root of n effect, and multiple processors, you get that small p denominator. You can figure out the minimum, and that can lead you to what the right trade-offs are between consolidation and dispersion. For optimal hybrids, there's this nice set of equations that I won't take you through, but the English basically says if the cloud is cheaper, you should use it. If cloud is more expensive, then don't jump to conclusions, because actually it turns out that hybrids generally are provably optimal. Back to my own a house and stay in a hotel argument, but again, you can formalize that and solve fairly easily. This leads you to a number of hybrid architectures, which I don't have time to get into, but there's kind of split transactions. There's send some traffic one place, some the other. There's a cloud burst scenario where you start with fixed resources and then you migrate on to on-demand resources, which in turn lead you to lots of interesting network requirements. Some of you in this room may have used the internet, which is an emerging technology that evidently is very cool. I've used it myself once or twice, and it's wonderful, but there's more to networking than the internet, and so these lead you to some interesting network requirements. Fiber channel, MPLS, VPLS, guaranteed network bandwidth, quality of service on demand, et cetera. I won't go into this. I covered the exponential demand growth issue. So in summary, since my time is up and I'm more or less on time, in summary, cloud is really cool. Keep studying. It's an emerging, rapidly growing industry. And it isn't just about core technologies like Perl or Ruby on Rails. It's also, there's some interesting problems viewed theoretically from the perspective of geographically dispersed computing infrastructures. And I think actually that axiomatic cloud theory reference that I just covered goes into some interesting perspectives, because again, the Turing machine, even though for those of you that know this stuff, goes into things like multi-tape types of variations, it still doesn't cover the geographically dispersed with delay issues that really define today's distributed processing paradigms. So with that, I'm on Twitter. I'm Joe Weinman, and I will say thank you, but I won't say questions because we're leaving those till later, right? Okay, thank you.